here, all right? You heard me. I'm going to write it down. You're going to copy it. We're going to get busy right now. All right, so get ready. Here we go. Everyone's got a benchmark review right in front of them, okay? And what we're going to do right now is go through it step by step, one step at a time. Are you guys ready for this? All right. All you got to do is follow my lead. Now listen, some of this stuff you already know. I don't want you to go ahead of me. I want you to stay right with me. As a class, we're going to go through each one of these, and we're going to get it done as fast as possible. My guess is we're going to get it done before the period ends, okay? But don't slow me down. Don't speed me up. Don't tell me to pause. Just keep on writing as fast as you can. You got to keep up with me. And if you have a question, you raise your hand. I'm going to pause the video and answer your question, okay? So let's keep working as hard as we can and keep those questions relevant to what we're seeing on this video. All right. Hey, here we go, you guys. The benchmark is tomorrow. The review starts right now. Everyone's got pencil and paper in front of you, and we're just going to go full speed ahead. All right. Hey, let me zoom in on this a little bit. Welcome back. Mr. Burke here, and we've got our benchmark review here. Let's get to it. All right. We've got this thing that you can barely see up on the screen, so let me go ahead and zoom in. We're looking at number one. Woo. All right. Hey, this looks cool. Now, I'm not using the actual smartboard software here. I'm just putting up a Word document, and I think I can write right over the top of it, so that's what I'm going to try and do here. Bear with me if I have any technical difficulties. I usually have this copied and pasted into my smartboard software, but in this case, we're going to try something a little different. All right. So here it is on number one. It says, hey, which property of real numbers was used between steps 1 and 2? Right here, okay? So what property do you see right here? The question is, how did we get from this to this? What does it look like we did there? Right, okay? We used the distributive property, because 4 times x equals 4x, and 4 times negative 3 equals negative 12. So between 1 and 2, we use the distributive property. All right, hey, that was a quick one. Ready? Let's go ahead and move on to number 2. Okay, this is where my technical difficulties come in here. All right, let's get rid of this. All right. So how do we simplify something that looks like this, okay? Well, we've got exponents on the outside, we've got exponents on the inside, and we got a big mess here. So here's what we do first, okay? We're going to raise everything to this exponent. Everything inside the parentheses is going to get raised to the third power. And there's a negative sign in front of that 3, so be careful as we go forward. Now, just do what I do, and pay attention here. The first thing we're going to do is say, what's 4 to the third power? No, we don't multiply 4 times 3. 4 to the third power is 4 times 4 times 4. So 4 times 4 is 16, times 4 is 64. Okay, forget about the negative sign right now. That's going to come at the end, right? Now, what's 4 times negative 3? Now we're going to look at this negative sign. What's 4 times negative 3? Negative 12. Good. Okay, what's negative 7 times negative 3? What's a negative times a negative equal? Positive 21. Good. Positive. Hey, you know what? Go back and erase that 64 for me, please. That was a mistake on my part. I didn't see it coming, but there it is. Big mistake. Okay, instead, what we're going to do for now is what's 4 to the negative third power? I'm going to say, oh, that's 4 to the negative third. Okay? We got to start off like this. And you'll see why in a minute when we send it downstairs, okay? So check it out. So we raised everything to the negative third power. 4 to the negative third. Bam. X to the 4th to the negative third is x to the negative 12. Negative 7 times negative 3 is positive 21. Catch up with me here. Because now we've got these negative exponents. And everybody say it with me now. What does a negative exponent tell you to do? Send it where? Downstairs, right. We're going to send this downstairs. Bam. We're going to send this one downstairs. Bam. Because of negative exponents. Hey, this one stays upstairs. Okay? Because negative times negative is positive and it stays upstairs. Here we go. So upstairs we've got y to the 21. And downstairs we've got x to the 12. And we've got 4 to the third. Ah. Okay? Now we can simplify. Ready? 4 to the third is 64. Okay? So here's how we finish it up now. Y to the 21 over 64, x to the 12. Bam. All right? Write it down. Hey, keep up with me here. I'm going to try and pick up the pace. I'm done with these technical difficulties. And I had a little stumble here with the 4. I didn't quite know what to do there. I had to figure it out. It's 4 to the negative third. Then we send it downstairs. And then we simplify. 4 to the third equals 64. Okay, write it down. You got to scroll down to 3. All right, here we are. What we learned in this class about multiplying monomials that have exponents is this. That first, excuse me, I got to get something to drink. First, if there's an exponent outside the parentheses, we have to deal with that first. Ready? So we're going to go 5 squared. T to the 4th squared is where we multiply 4 times 2. 8. U squared squared is 2 times 2, u to the 4. And v squared is just v squared. Okay, and there's no exponent outside this parenthesis. So we can just take it out of the parentheses. Now we got 5, t to the 3rd, and u. All right, now, you might be thinking, combine like terms, and you're sort of right, but it's not combining like terms. It's multiplying powers. So first, we're going to take 5 squared and 5, because they're the same power. I mean, they're the same base. They both have 5. Ready? So 5 squared times 5 is the same as 5 squared is 25. So 25 times 5, okay, is 125. Now, what about t? Well, here's another t over here. So what's t to the 8th times t to the 3rd? Be careful. When we multiply powers, we add the exponents. So t to the 8th times t to the 3rd is 8 plus 3, t to the 11th. Okay? Now you try. What's u4 times u1? Right, u5. Okay? How about v? It's all by itself. There's no other v's over here, so it's just v squared. Okay? And that's everything. Okay, first we had to raise everything to this power. Everything inside the parentheses gets raised. This is first. And that's how we got this right here. Okay? Then we started multiplying common bases. Okay, the 5 and the 5 got 5 squared times 5 is 5 to the third power, which is 125. T8, T3, T11. You guys got it? All right, good. Let's see if I can get you on a D-try because my voice is cracking. I need to get something to drink here real quick. All right, now we talked about this one. On a, you remember this thing? It's called a radical. And we said, hey, look. If you're asked to find between which two integers this goes, here's how you do it. Ready? Radical 74 lies between two integers. And remember what integers are? They're numbers like 1, 2, 3 integers, right? 0, -1, -2. It's like a number line. So these are called integers. And between what two consecutive integers are we going to find radical 74? All right? So here's how you do it. What perfect square is just above 74 and just below 74? And I say, oh, well, we got radical 81 and radical 64. Okay? Radical 64, the square root is 8, and radical 81, the square root is 9. Do you see how 74 is between 64 and 81? You got to find those two perfect squares that are on each side of 74. And then take the square root and say, the square root of 74 is in between 8 and 9. So here's your answer. Bam, 8 and 9. Okay, write it down. Maybe you don't understand it completely. Write it down. The square root of 74 is somewhere in between the square root of 64 and the square root of 81. 74 is between 64 and 81. The square root of this is 8, the square root of this is 9, so the square root of 74 is somewhere between 8 and 9. All right, we're going to simplify this thing. Ready? You remember how to simplify radical? Okay, 5 is on the outside, and 24 is 2 times 2 times 2 times 3. Okay, 4 times 6, right? Bam. So what do I underline and get rid of? Well, I got two 2's, so I'm going to get rid of a 2. Bam. Is there 2 of anything else? No. So I can't take anything else out. I'm just taking out a 2. Ready? Now, when I take this 2 out, what do I do with the 5? Yeah, I'm going to multiply 2 times 5. Ready? So that's 10 on the outside and 6 on the inside. Okay? See how 6 is still on the inside? Write it down. Yeah, we just went over that a few weeks ago. No big deal. All right, here we go. Okay, this thing's called absolute value. And this is the one where we're going to be writing two equations. Remember this? Okay? But the first thing you got to do is you got to get the absolute value all by itself. We got to get rid of this, and we got to get rid of this. Okay? See where the equal sign is? So on this side of the equal sign, we're going to get rid of this, and then we're going to get rid of this. Ready? How do you get rid of minus 4? Plus 4 on both sides like that. Bam! We got rid of it, right? So now we got 4, absolute value, 7x plus 1. Write it down. Don't wait for me. Well, yeah, wait for me. Okay, write it down now. Okay, now, we have to get absolute value by itself. On this side of the equation, okay, we got to get rid of this. How do you get rid of multiply 4? Yeah, there's multiply 4 here. In front of the absolute value, it's being multiplied by 4. And the opposite of multiply is divide. Bam! That's how you get rid of it. Over here too, though. Just like that. Ah! Mr. Burke, you're awesome. Yeah, I know it. Okay, here we go. Ready? Absolute value, 7x plus 1 equals. Look at this. We got the absolute value all by itself now. 20 divided by 4 is 5. Ah! Now, the magic kicks in. This is where we're going to write two equations instead of just one. Okay? Remember how these work? It's going to be 7x plus 1 equals 5, and 7x plus 1 equals what? Negative 5. Good job. Here we go. The absolute value of 7x plus 1 equals 5. Okay? And we got there by adding 4 and then dividing by 4. Okay? And then this is where we are. Let me know if this is wrong. I don't know. I'm pretty sure this is right. Add 4, divide by 4. Okay, good. Now that we have the absolute value by itself, we're going to write two different equations. The first one is 7x plus 1 equals 5. And there's no more absolute value because we're writing two equations. The absolute value bars go away. And the other one is 7x plus 1 equals negative 5. And then you just solve both those equations. So we're going to come up with two answers. Ready? We're going to subtract 1. Bam. 7x equals 4. And then you get x by itself, you divide by 7. So your first answer is 4 sevenths. And over here, we're going to subtract 1. And negative 5 minus 1 is negative 6. And then we divide by 7. Bam. So your other answer is negative 6 over 7. Okay? Write it down. Okay, hey, you try. Okay, you do this one. I'll give you a clue. Distributive property, and then combine like terms. Oh, yeah. You go, girl. All right, so let's get going here. Yeah, I stole it from my wife. Give me a break. All right, here we go. 10 times 7x and 10 times 4. So that's 70x plus 40 plus 8x. Is this really this simple? Let me see if this is simplified. Okay, great. This is easy, you guys. This is what we're doing in algebra readiness. This is nothing. Okay, ready? Distributive property, and now we're going to combine like terms. What's 70x plus 8x? 78x, right, plus 40. And you're done because you can't combine those. They're not like terms. They have to stay separate as a binomial. They're not like terms. They have to stay separate, like a binomial. Okay? We could add 70x and 8x, we turn that into 78x, because these are like terms. They both have x.